Hello students, welcome to video lesson 8.3. In this video we're going to continue our discussion of linear equations, and specifically in this video we're going to talk about the intercepts of a linear equation, what they are, how we can find them, how they will help us to graph linear equations. All right, so the intercept of a graph in general is the point or the points where that graph crosses the x or the y-axis, okay? So whenever a graph of a line, in our case for right now straight lines, but it doesn't have to be. As we continue on in math class, we'll get curved lines and things that will cross over the x-axis or the y-axis, okay? And the points where they cross are called intercepts, okay? So we have x-intercepts, meaning the points where we cross the x-axis. We have y-intercepts, where we cross the y-axis, okay? Every linear equation, I shouldn't say every linear equation, most linear equations have one of each, okay? One x-intercept, one y-intercept. And our goal today is to find those, okay? So if we look at a graph, for example, this is sort of what we're talking about, okay? So here I have a blue line that crosses the y-axis right down here, and it crosses the x-axis right here. So the intercept values are just the values of x or y where the graph crosses over the axis, okay? So the x-intercept is here at x equals 2. That's where the blue line crosses over that x-axis. So the x-intercept is x equals 2. Okay, and then the y-intercept, where it crosses the y-axis, is down here at -5. So my y-intercept is y equals -5. Okay, so this is sort of what we're talking about. Now, when we look at an equation, we can do a little bit of math to find the x and y intercepts, and then we can actually use those intercepts to pretty easily graph the linear equation. So if we look first at y equals 3x minus 6. And we use this equation to sort of talk about how it is that we find the intercepts from a graph, okay? The thing that it is important for us to know or to remember is that when the graph, let's say, crosses the y-axis, okay, that means the point where it crosses is somewhere on this y-axis. And the thing to remember is at any of those points, the x value must be 0. Right? Because I'm not to the left or right at all. I'm right down the middle of the graph. So the x value has to be 0. So to find the y-intercept, and I will maybe write that up here for you guys, to find the y-intercept, we plug 0 in for x. Okay, that's going to be our strategy to find the y-intercept. And then similarly, to find the x-intercept, we will just plug 0 in for y. Because when we cross over the x-axis, right, when we cross over this x-axis, the y value at any of these points where we cross must be 0. The y value must be 0 if we're going to cross over that x-axis. So we find the intercepts by simply plugging 0 into the equation for each variable and then trying to solve for the other variable or get it all by itself, okay? So if we look at this first example, y equals 3x minus 6. If I first want to find the y-intercept, I'm going to plug a 0 in here for x. So my equation is then going to say my y value, which is going to be my intercept value, is equal to 3 times 0 minus 6. And now I can just do math, right? 3 times 0 is 0 minus 6. Well, 0 minus 6 is -6. So y equals -6 is my y-intercept. Okay, this is my y-intercept. And I know that because that's the value of y when x is 0. So if I plot that on the graph, right, x was 0, comma, -6 for my y, 0, -6, 1, 2, 3, 4, 5, 6 is right down here. And that is of course, where I'm crossing that y-axis. That is the point of this graph that's on that axis. So we find the y-intercept by plugging 0 in for x. And then we can also find the x-intercept by plugging 0 in for y. Okay, so I'm going to take this stuff away. Pause the video and write it down if you need to. But I'm going to take this stuff away. And we're going to change the equation from, instead of plugging 0 in for x, I'm going to plug 0 in for the y variable. Okay, and that is going to change some things. And I'm going to have to do a little bit of extra math to solve then for my x-intercept. Okay, so again, I'm going to take 0 and I'm going to put it in for y. So the whole left side of the equation is just going to say 0. And that's equal to 3x minus 6. And now my job is to get the x value alone, because I'm trying to figure out what does x equal in this case. Where on my x-axis am I crossing over where's this graph crossing over my x-axis? So remember, in order to get the x by itself, I have to undo the things that I see being done in the opposite order of operations. So I'm going to undo the minus 6 first, because that's at the end of the order of operations. And I do it on both sides, right? Whatever I do on one side, I do on the other. 0 plus 6 is 6. That's equal to 3x. Remember that 3x means 3 times x. And so I can now divide by 3 and divide this by 3. And now I just have x alone on that side, and the other side says 6 divided by 3. Well, 6 divided by 3, that's 2. Okay, 6 divided by 3 is 2. So my x-intercept value is x equals 2. Okay, x equals 2. And I know that because if I plug the 2 back in, 3 times 2 is 6. 6 minus 6 does give me 0, right? So my x-intercept, 2, 0, x equals 2. If I go to x equals 2, I cross right there, okay? Now, once I have found my 2 intercepts, y equals -6, x equals 2, if I plot those on the graph and I take my straight line tool and I connect them, well, that's the graph of the equation, right? So, because I only need 2 points to connect to make a straight line. So when I find my intercepts and I plot them on the graph, I don't have to do any extra work to actually see the graph of the equation. Okay, because this is the graph of this equation. I can graph the function or graph the line just by the intercepts, right? So that's one example of finding the intercepts, plot them on a graph, and then connect those with a straight line, and you have the graph that you wanted, okay? So we're going to do one more example of this. And I'm going to change this equation to look slightly different, okay? So this equation doesn't quite look the same, but we can follow exactly the same strategies for finding the intercepts, okay? So let's look at the equation 4x plus 3y is equal to 24. 4x plus 3y is equal to 24. If I start plugging 0 into these, for these variables, I will find my intercepts, right? I'm going to start again by finding my y-intercept. So I'm going to plug a 0 in for x. Okay, I plug 0 in for x. So this now says 4 times 0. This still says plus 3 times y is equal to 24. And I'm going to do math, do algebra to try to figure out what does the y value have to be. Well, 4 times 0 is just 0, right? So 0 plus 3y is equal to 24. But does it matter that I'm doing 0 plus 3y? No, because that just equals 3y. So this 0 is just gone, and then I don't need the plus sign anymore either. So my equation now says 3y equals 24, and I just have one step to solve for that y value, dividing away the 3, and I end up at y equals 8. Okay, y equals 8. 24 divided by 3 is 8. So if I go on my graph and I plot that then, 2, 4, 6, 8 is right up here. So I plot that y-intercept up there on my y-axis at 8. Okay, So I plugged 0 in for the x, and then I do math. Okay, then I use my algebra skills, my solving equation skills, to find that y value. Okay, so if I go back then and I find my other intercept, I want to find my x-intercept. Where do I cross the x-axis? I'm going to plug 0 then in for the y variable. So 0 goes in there, and this becomes 3 times 0. The front part still says 4 times x plus 3 times 0 is equal to 24. So 3 times 0, again, is 0, right? So this now says 4x plus 0 equals 24. But 4x plus 0, well, the 0 doesn't really matter, right? That just disappears. By plugging the 0 in for that y variable, that whole term just goes away. So the rest of the equation then says 4x equals 24. I can divide away the 4, and that will give me my x-intercept value, okay? And I arrive at a value of x equals 6. 24 divided by 4 is 6. So if I go to my graph and I plot that intercept value, meaning on my x-axis, I go to 6. 1, 2, 3, 4, 5, 6. That's right here, okay? And then if I connect those two intercepts with a straight line, I have now graphed this function. Okay, and I can put my arrows on the end, and I have made my graphs. Okay, so this is another way that we can graph a linear equation. Now, making a table of values like we did in our last video is still perfectly fine, but it's potentially faster if we can get good at this finding intercepts, plug 0 in for this variable, solve for the other one, and then redo the process, plug 0 in for this variable, solve for the other one. We find those two intercepts, we can plot those on the y and the x-axis, connect them, and we have our line, right? If you have any questions about finding intercepts, do please reach out to me at some point, somehow, and I would be happy to help you or re-explain or walk you through some more examples. Otherwise, that's all I have for you right now, and we'll talk to you soon.